Okay, just a short recap in case that all those matrices get you a bit confused. So I will try to explain this in a slightly different way and in a compact form. The main goal of stereo vision is to retrieve the depth information from a scene, because using one single camera we can know where a point is but know how far away. In other words, we know the relationship between the image coordinates that we know that are UV and the world coordinates denoted by X and Y. But we don't have another variable in the image to find Z. In simple stereo, both cameras are aligned, and the only difference is the distance between the origins of each camera. So there's no rotation, and the translation happens only in the x-axis. So in order to find the projection from one camera to the other, we will use the perspective projection equation. This equation defines the relationship of each point in the image and the real point in the world. Here is where we include the translation to the formula of one camera while the other stays the same. Then, solving the linear system, we can find Z. Now, in uncalibrated stereo, the procedure is the same, with the only difference that the second camera has both a difference in rotation and translation. If we knew what is the rotation and translation, we do exactly the same that in simple stereo. We take the perspective projection equations of each camera and we include the translation and rotation to the formula of one of them. And then we obtain the projection from one camera to the other. And we can solve again the linear system to find Z. What makes the example of uncalibrated stereo a bit more complicated is that regularly we don't know what is the translation and rotation of the system. So we need to calculate it. We start by using the epipolar constraint that describes the relationship between the two images. Remember that one way to write this constraint is like this, where F is the fundamental matrix. So we take a sample of at least 8 corresponding points on each image to build the linear system and find F. F contains the rotation and translation of the system in the image coordinates, UV, but we need this in the world coordinates to find Z, and that we find in the essential matrix E. Now, E is basically F multiplied by the parameters of each camera K. So we can easily find E because we know KR and KL. Now that we have E, we can use singular value decomposition to obtain the rotation and translation of the system in the world coordinates. And we can build the projection matrix from one camera to the other. Okay, I hope that this helped a little bit to understand the process. Now you can come back and watch the previous video again to consolidate the matrix form, because in the quiz I will ask about the characteristics of those matrices. Okay, see you next week.